Hello friends, so to solve this, we will arrange this a little bit. 575 minus the square root of n. Next, we'll raise both sides to the power of 2. 575 minus square root of n, all to the power of 2. This will give us m is equals to square root of 575 squared plus square root of n squared minus 2 square root of 575 n, and m is going to be equals to 575 plus n minus 2 square root of 575 n. Okay, and it's stated that m is a positive integer here. Okay, so if that is the case, then this is a positive integer, this is an integer. That simply means that this has to be an integer. Okay, so let's simplify this a little bit. So 2 square root of 575n is the same as 2 into square root of 25 times 23n. Okay, and this is 2 times 5 into square root of 23n, and this is 10 square root of 23n. So let's rewrite the main expression. So m is equals to 575 plus n minus 10 square root of 23n. Okay, and we'll still maintain that m is positive integer and n is also a positive integer. Okay, so with that, for m to be a positive integer, this is an integer, this is an integer, this term has to be an integer, and for that to be possible, that means that square root of 23n has to at least be an integer. Okay, and for this to happen, if you look at this clearly, 23 is a prime number. It's only divisible by 1 and itself. So for this term to be an integer, 23n must be a perfect square. Okay, so for 23n to be a perfect square, n has to be of the form 23 times another perfect square, where x is a positive integer and x cannot be 0, because if x is 0, that means n is going to be 0. So clearly we've established the form of our n to be 23x squared. And if we follow the same process and we made square root of n subject formula here, not m, we would arrive that m is going to be of the form 23y squared, where y is a positive integer. I'll allow you to do this. To get this m, all you need to do is to solve this expression, and you are going to arrive at this. So clearly, we've gotten the form of our m and our n, which is 23y squared and 23x squared. Okay, so the next thing we're going to do, we're going to put this back into the main problem. So we have square root of m plus square root of n square root of 575. So let's substitute this term. So this will be 23y squared plus square root of 23x squared. This is equal to square root of 575, which is square root of 25 times 23. And here we have y into square root of 23 plus x into square root of 23. This is equals to 5 into the square root of 23. So if we divide both sides by the square root of 23, we are going to have that y plus x is simply equals to 5, and y and x are positive integers. So we can easily make a table here showing the various values of y that corresponds with that of x. So if x is 1, y will be 4. If x is 2, y will be 3. If x is 3, y will be 2. If x is 4, y will be 1. So we have the matching values that can satisfy this expression. So let's put back our m comma n, which is 23y squared comma 23x squared. So let's try for this very first set, 1 and 4. So this is simply going to be 23, y there is 4, times 4 squared comma 23 times 1 square, which is just 23. So that means we're going to have 4 solutions for our m and our n. So let's make a bigger set. So m comma n is going to be the solutions, will be in this set. We've already found the first one, 23 times 4 squared comma 23. This is the first solution. The next is going to be 23 times 3 squared comma 23 times 2 squared. Next will be 23 times 2 squared comma 23 times 3 squared. And last but not the least, 23 comma 23 times 4 squared. And this is the solution set for our m and n. So each of the solutions is going to solve our problem. And that's how we solve this kind of problem. Thank you very much, guys. And please do subscribe.